Hello everyone, I'm Alfian and today we are going to solve the HackerRank challenge on the data structure section called the insert a node at a specific position in a linked list. And for this challenge, it says given a pointer to the head node of a linked list and an integer to insert at a certain position, create a new node with the given integer as its data attribute. Insert this node at the desired position and return the head node. A position of 0 indicates the head, a position of 1 indicates one node away from the head, and so on. The head pointer given may be null, meaning that the initial list is empty. For this example, the head refers to the first node in the list of 1 and the next list is 2 and the next linked list is 3. And we have the data of 4 and the position that needs to be placed in position 2. So in short, we are inserting the data of 4 of the node of inside the position number 2. So since the position number 2 has the 3 right here, which is the node, then the 3 will be unchained from the 2 and the 4 is placed before the 3, and after that the 3 will be chained with the 4 and 4 will be chained with the 2. So 4 will takes the precedence of 3, and the function description says complete the function insert a node at position with the following parameters. Linked list node pointer linked list a reference to the head of the list, and the data parameter an integer value to insert as data in the new node, and the position parameter an integer position to insert the new node, which is 0-based indexing. So we have another example. Input right here, we have the linked list of 16, 13 and 7, and we have the data of 1 and we need to insert the data at the position number 2. So we need to place the 2 after the 13 and before the 7. So the 7 will be replaced by 2 and 7 will be placed after the data of 1 right here in the position number 2. Okay, so since we are using the Java 7, let's call this part of the code, and we have the function right here called the public static singly linked list node, the expected returning data type of singly linked list node, and the function name is the insert node at position and takes 3 parameters. The first one is the linked list in the form of singly linked list node, and the second one which is the integer of data, and the third one which is the position in a form of integer. And so before that we have the red underline right here, cannot be declared as static. Static method can only be declared in a static or top level type. Since we are working on Java 7, then we will have this kind of error. I don't know, maybe it's from the HackerRank. Maybe they need to fix this part. And for another language using the TypeScript as example, we don't have that kind of error. It is just the expected output from the function. Since we are not returning anything, then of course if we declare the return right here, return as the linked list, then of course the red underline will goes away. So let's go back to our Java 7 implementation and let's move this part from the top. Let's cut this part and go outside from the curly brackets of the result class right here and place the function outside of the result class. Let's indent this and let's write our code. So for the first one, we need to declare our linked list node data type called the new node, and we construct a new node with that takes one parameter called the data, contains the data from the parameter right here. And for the next one, we need to an edge case to check if the desired position is 0 with the, in other words, using the position index. Since the position is always using the index right here, also position 2 will replace 7 with data of 1 right here. So we can assume that position 2 is in a form of index. Why is it index? Is because the 16 right here is pointing to the position of 0, and the 13 right here we have the position of 1, and the 7 right here we have the position of 2. So that is why the number 1 right here of the data 1 is placed on the position 2 that takes the precedence and moving the 7 to the next one. or the next node of the data one right here. And so we need to write an if check. Okay, so write if the position is already on 0, then we can simply move. Let me visualize this. Let's say we already have the linked list node right here. Linked list node already declare linked list 1 or linked list 2, and linked list 3 like this. So since the position takes the 0, then of course the linked list 1, 2, and 3 will be shifted to the right, and the new node will be placed on the top of the linked list chain. We need some kind of approach to make the new node takes the first position before everything else. So since a node class has the value of data, which is the data that we declare from the constructor right here, and the second property, which is the next, then of course we can use the next property to assign the linked list right here, to assign our linked list, and that way the new node will be placed before all of the existing linked list. So in order to do that, we can simply declare the new node that we already declare, new node that takes the next property and assign our linked list, and then we can simply return new node as our new node instead of the linked list. Since we already assigned the new node dot next, then of course we need to return the whole new node in a form of the complete list from the return like this. Let's say we have the new node as the NN right here, and the rest of the list is placed after the new node. Okay, so for the next one, if the position is higher than 0, or if it's index 1, or if it's index 2, or position 2, or position 3, and so on and so forth, then we can simply declare our pointer called the current node. We can simply declare another single linked list node data type called the current node. It is a little bit different than the new node. This current node acts as a pointer that takes the same form of node chain of the already declared linked list right here. And then for the next one, we need some fixed pointer or fixed iterator to find the position that we need to place the new node right here as a chain of the existing linked list. So in order to do that, we need let's say we have the 16 for the sample output right here. We have 16, 13 is in the arrow sign right here to resemble the next property, and then 1, not 1 but 7, and then we need some kind to iterate over the already existing linked list. So that way we can simply place our new node to the list and shift, if it's already there, shift it to the right. And since on the previous challenges we use the while loop to check if we already on the tail of the existing linked list or not, and then the while loop will loop through until it hits the end of the linked list chain. But for this one, we need a different approach by using a fixed iterator to point out the specific position or direction that we want to place the new node. So in order to do that, we can simply use the for loop using the integer I equals 0 as long as I is below the position, using the -1 since we are working with a position using the array. Then you can simply use the I++, and then to move the current node pointer, let's say we have the current node that points to the 16 right here, to the first part of the linked list, and we declare current node pointer right here. And then after the for loop checking the position of the current node, then we can iterate of the linked list using the current node linked list node right here, and that way the current node will move to the next one and then to the next one until the for loop stops using the desired position that already declared as the parameter right here. So using the current equals current node dot next. I'm sorry, I forgot to use the current node instead of just current. And then for the next one, that way the for loop will iterate through the already existing linked list node. If it's 2, then of course the current will point to the index number 2. Let's say current I0 and then pointing to the next for the first iteration, and then for the next iteration it is pointing to the 1 and then pointing to the 2, and then it will stop pointing the second position, and then it will stop. This is the current place. And then how do we assign this? Of course we need to first assign the current node of the existing linked list. We can assign the new node dot next, which is the created new node right here, and then the next property will take the current node dot next. So that way we are assigning the 7 right here as the chain of the new node next, and the new node next will be placed before the current node dot next, which is the node of 7 right here. And for the next one, we can simply declare our current node dot next, which is the 13 right here, and we can assign the new node as our node from the created node right here with the data. And that way we are using the 13 right here as our current node. It's 13 right here, 13, and the next will be the new node, the current node dot next, which is the 13 right here, and assigning the new node. And before that it is 7, which is the current node dot next, and before we place 7 we place as the new node dot next, which is the new node dot next. We place 7 after the new node, which is the next property right here, and that way we have the 1 and we assign the 7 after the 1, and we should return the linked list instead of the current node. So let's run this to see if it works. And it's all completed. Let's submit this. Okay, so that's about it. I hope you understand my explanation. If you still don't understand, you can ask me in the comment section, or if you have any better solution regarding this challenge, tell us what you think in the comment section. Thank you for watching the video. I hope you have a great day, and I will see you in the next video. Goodbye.